I believe I am live now. Do let me know, like people in the chat, like how many problems are you guys able to solve? I have a poll ready, and we are planning to discuss all the problems today. So, like overall plan would be we would discuss A to E as usual. I will say like what are the ideas I have for problem A, and then we will try to code problem F as well. So yeah, like essentially, I saw someone mentioning trip, and I realized how we can solve it using trip. So that's where, yeah. Okay, yeah, like I'm getting hacked verdict on problem. Wait, 1100 has been hacked. So I have a lot of submissions on me. I hope one of them will survive. At least this is a submission that has 187 times. Alright, thinking back, I'm not sure if I know how to solve F or not, but let's see. Mm, um, okay, let's see. Like, let's just wait for a couple of more minutes and then we will get started. So, like, people in the chat, like, how many problem? Like, do you have any questions for me? Like, because we are waiting for 2, 3 more minutes more, and then we will get started. Okay. In C, my obsession was we add or remove count of unique elements from the array, and to make n equal to k, the difference n minus should be divisible by unique k. I did 3 in 4, got TLE, but I had logic, I think. Okay, Vivek says 2. So just a couple of more minutes and then we will start. Like, do let me know if you have any questions for me. Like, I would be waiting for 2 more minutes for more folks to join in, and then we will get started. And do comment on the poll, like how many problems you guys solved. So looks like most of the folks are on 1 to 2 or 3 problems, and then very few people on 4 or 5, 6 problems. Hmm. Wait, my voice is echoing. I hope it's not. Like, can anyone also confirm it's echoing? Because at least the setup looks accurate to me. Okay, echo. Like, let me check with my earphone. Hello, hello. Bigrams, predominant frequency division, unstable elements, 2 digit string, product of closure, summer vacation. Hmm. At least voice looks fine to me. Like, do you have the Codeforces tab also open and the YouTube also open? How and where to practice DP problem? Like, you can try at Coder DP contest. Like, here you will find few standard problems on DP. And actually, you can join in my Discord server. There, I have advice on how to practice XYZ problems. Mhm. Mm. Mm. Let me turn on streamer mode. Oh, wait, 1 sec. You can join in the Discord server and check out like roadmap to Red channel. Here, like how to like I have very specific answer like how to practice standard problems on topic X, let's say DP, and you can go over this. I think let's get started now. It's been around 5 minutes, so most of the so let's start from problem A. It says bigram. A bigram is a string. In a string is a pair of adjacent characters. For example, in the string hello contains 8 bigrams He, El, Ll, Lo, Oi, El, Ll, Lo. Monograph has cards with letter C1, A and C2 cards with letter B and CK cards with letter K of the Latin alphabet. He wants to make a string from these cards using each card at least exactly once. The resulting string must contain at least 2 equal bigrams. The order of the characters in each bigram matters. For example, in the string ABA does not have 2 equal bigrams. Determine whether it is possible to make a string that satisfies these conditions. So, like the problem statement says, in a string we define bigram as 2 equal characters. For example, if we have hello, then HE is 1 bigram, EL is another bigram, LL is another bigram, LO is another bigram, and so on. It says we are given number of A's in a string, number of B's in a string, number of C's in a string, number of D's in a string, and so on. Now it says, can we arrange the characters in some way to form a string that contains 2 equal bigrams? Essentially, it means can we have some string like this, some characters? Let's say we have AB here, some characters, and then again AB here, and so on. Like that would be the case, right? For example, in this case, AB would be one bigram, AB would be the another bigram. Like AB can be another character, like essentially some string. Then we have 2 characters equal X and Y, some more string, then X and Y, and some more string. Like this is definitely possible. If you have 2 characters, 2 character with count greater than equal to 2, then the answer is definitely yes. Let's say we have D 5 times and G 7 times. Then we can keep DG nearby some strings, DG, some more strings, DG, and some more string. It doesn't really matter how we arrange the remaining characters, this would always be equal. And if all the characters are ones, then the only except if we do not have 2 characters with count 1, it means we have only 2 characters greater than equal to 2. The answer is yes. Another option can be 1 character with count greater than equal to 2 and rest less than equal to 1. In this case, can you see how you can form, like you can definitely not form bigrams using the string that appears only once. then the only way we can have is like we repeat same character multiple times, some strings, B, few more strings, and so on. So like the requirement here is if we do not have two characters with frequency more than one, then do we have one character with frequency greater than equal to 3? In that case, keep them combined. So you have this as the first bigram and this as the second bigram. So print yes, otherwise print no. And that is essentially the complete solution here. Any questions, anyone? Like you can even simplify it to some statement saying the number of total characters should be greater than equal to k plus 2 or things like that. But this is where we are. We take input all the strings and we sort them in decreasing order. If we have one character with frequency more than 3, then the answer is definitely yes. Otherwise, if we have two characters and we have frequency of both of them more than 2, then also the answer is yes. Otherwise, we have to print no. And this is essentially the solution for problem A. Any questions, anyone on problem A? If not, we will move on to the next problem. Just one more call if any questions, anyone. Otherwise, we will move on to the next one. Just one more minute. Yeah. Clear, clear. I see. Just react something in the chat so I know that, yeah, it's clear. Okay, let's move on to the next problem. It says predominant frequency division. You are given an array consists of numbers 1, 2, and 3. Check whether it is possible to split it into three continuous non-empty parts such that for each part I equal to 1 to 3, the following condition holds true. The number of elements greater than I is at most half of the part. In other words, you need to divide the array A into three pairwise disjoint non-empty parts so that in the left part the number of ones is at least the total number of twos and three. In the middle part, total number of ones and twos is at least number of threes. And the right part can be anything, but it must be non-empty. Like this is an important constraint. For example, the array 2, 1, 1, 3, 3, 1, 2, 3 can be split into three parts 2, 1, 1, 3, 3, 1, 2, and 3. Here you can see like the number of ones is 2 and 2 and 3 is just 2. Here you can see in 3, 1, 2, like the number of characters more than elements more than 2 is just 3. So this is also good. And then we have 3, we can have anything over here. And the array 2, 1, 3, 3, 3, 2, 3 cannot be split into such a way. So this is where we are. Any questions, anyone on the problem statement? So like the problem statement is like this. We have been given an array of A1, A2, A3 up to A. we have to divide it into three parts. Let's say this is part one. The ask is here the number of should be greater than equal to, like it says actually half count 2 plus count 3. Here the ask is count 1 plus count 2 greater than equal to count 3. And the only ask here is length should be greater than equal to 1. This is the problem statement. Okay, we have to divide it into three parts, and these are the conditions three parts must satisfy. Any questions, anyone on the problem statement still? Like, it's up to us to decide how to split it into some parts. But once we have decided how to split it into different parts, then we need to say like whether such a split is possible or not. So, like the way that first idea that comes to my mind is as follows. Start with the first element, A1. Start from here and keep counting number of ones, 2 and 3. The moment count 1 is greater than equal to count 2 plus count 3, break here. No, we cannot sort the array. Like we cannot change the order of elements. Otherwise, it would have been easy. Like just take first element as one, second element as one or two, and everything else as three. The moment we find the first time the number of elements is more than count one or two, break there. Then you start again. Now you keep counting. And the moment you have count one and two greater than count three, you break. Basically, you start count from here again. So this was my first intuition. Unfortunately, it gets a WA. Consider a test case like this. We have 1, 3, 3, 2, 3, 3, 3. Now, the moment, if we start from here, the moment count of 1 becomes greater than 1, we break, then we will just end up here. Then if we proceed further, then we will start taking this, this and this. If we take this, then count 2 is 1, count 3 is 2. And then count of 3 will only increase. And this is not a valid part. Like we will never find the part when the count of 3 becomes more than 1. So the next option becomes like if we take this as the one part, then here count 1 is 1, count 3 is 1. The equation is satisfied. And the next part can be this. Here count 1 is 1, count 3 is 1. This is also satisfied. This can be anything over here. And we actually have samples where this assumption no longer holds true. So like the problem for me becomes as follows. For each element, figure out if we start from here. If we start second part from here, can we get for each element count? Okay, if we start from here, do we have some endpoint here such that we can get this count? And then we also know the number of ones, two, and three in starting. So we can also check if in starting if we have count 2 plus count 3. And the moment we find a valid pair like this, we will say we are done. So the idea is for each index, we find if we can start second part from there and we can get the required number. Any idea, anyone, like how we are going to do that? So the idea can be as follows. First, you need to leave an for the third part. You keep running from here. You take count of and count 3. You keep these two variables with you, no binary search, nothing like that. You keep these two variables with you, count 1, 2, and count 3. And whenever count 1, 2 becomes less than count 3, abandon that part and restart counting. So the way, for example, in a real array, it would look like this: 2, 1, 3, 3, 3, 2, 1, so on. When you are here, count 1, 2 is actually 1, count 3 is 0. So yeah, like the answer is yes. If we start from here, we can find some part here. Now you go here, count 1, 2 becomes 2, count 3 remains 0. So the answer is yes for this as well. Now when if you start from here, count 3 becomes 1. The answer is still yes for it. Then you go here, your count 3 becomes 2. The answer is still yes, because your count 1, 2 is greater than equal to 2. Then you go here, your count 3 becomes 3. And now the count of 1, 2 is more than less than count of 3. So that we can, I would say we cannot start from here. And with that, I would also reset my counting as well. Now I go here, again count 1 becomes 1. So the answer is yes for this part here. And then I have this count becomes also 2. So yes, that I can make the second part. And then counting for the first part is easy, and you can have anything for count 3, so it doesn't really matter. And essentially that's the idea for the problem B. No, we are not binary searching or doing anything as such. We start from the last index. If count 1, 2 is there, then we increment it. Otherwise, we increment count. Now we say that we can start forming second index from here and end somewhere else if count 1, 2 is greater than count 3. If count 1, 2 becomes less than count 3, make count 1, 2 equal to 0, count 3 equal to 0. And we have to skip the very last index, so we cannot do anything. Then we can also do the same for count 1 as well. Like, I really doubt we can do a brute force here. So, like, this is also an order and solution. If count 1, if we can form a part from 0 up to index I, and we can form part 2 starting from I plus 1, then is possible is true here. And this is where we are. It looks like, did I miss something somewhere? No, I cannot do a reset for the first part. So this was problem B. Any questions, anyone? By the way, like, do check out one of the Chrome extension that I have created. Yeah, you can find like my video editorial direct link here if you install that Chrome extension. And you can find even others video as well using the search here. It's available on both Firefox and Chrome. And do put in a rating or review if you want. So any questions, anyone on problem B? Like, the overall idea is, what we need is two things. If I give you an index I, 0 to I, can this be the complete? This is one question you have to answer. And another question is, can I start from I plus 1? And form a valid part 2. These are the only two questions you need to answer. If the answer is yes for both of these, then you are good. Checking this part is easy. You can keep a track of how many ones you have found in between 1 and 2 and how many 2 and 3 you have found in these two. And you are done. The things become a bit tricky here because there is no end point you are predominantly deciding over here. So my idea is like you start from the end. Whenever your count 3 becomes greater than count 1, 2, we abandon that part and restart counting. And that's all I have to say. And then there was whole algorithm on how to solve for this one. You start from the last index, you keep a count of 1 and 2 and count 3 you find. If your count 1, 2 is greater than count 3, you can say that we can have a second part starting at the index I. And if count 1, 2 is less than 3, we restart the counting. And then for the first part, it's even simpler. We start with count 1 and we have count 2 and 3. We maintain the same counter if count 1 is more than equal to count 3. We cannot restart the counting because the first element will always start from the index 0. And at last, we can check if we can we have first part from 0 up to index I, and can we have second part starting from index I plus 1. And that's all I have to say. So any questions anyone on problem B? This is big of order n. This is one for loop and this is one for loop. Both of them runs in order n. This is also one for loop. So overall it's order n. And that's also the time you need to take an input as well. I kind of brute forces. My approach was to use an increasing sliding window from left and running an inner loop to find the right valid increasing slided window when left is valid. Like there are ideas that will work over here. Any questions, anyone? Looks like some of my more submissions got hacked. Like I'm hopeful this one will survive. This is just 187 seconds. And I believe all of these are TLE. This is problem divider. TLE. 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 How do we start Codeforces? Join in the Discord server I have. And check out this channel roadmap to RAD in 2 minutes. It has answers of all the questions that you need. Like it contains like how I approached problem back in the day when I was quite actively doing competitive programming. Any questions, anyone? Last call. No, like actually it's already quite too late. I'm rethinking whether I should code for F or not. Like it's past midnight for me. Like I had to delay this stream by 1.5 hours for some reasons. And this is where we are. And also thanks everyone for still joining in here. I believe most of it's past midnight for you guys as well. So that's where, yeah. Do give me a signal that we can move to the next one by reacting something. Okay, let's move further. Problem C. Unstable elements. You are given a sorted array of integers a1, a2 up to an. We can perform any number of operations on following types of the array. Mark the first element of the array as well as all the elements that are not equal to their left neighbors. Then either delete all the marked element or duplicate them. That is, replace each marked element with the two identical elements. For example, consider the array 1, 1, 2, 4, 4, 5. We have marked the first element. We have marked 2 as well. We have marked 4 as well. We have marked 5 as well. And if we delete the marked elements, we would be left with 1, 1 and only 4, 5. Only, not even 5. Or if we double the marked element, then we will have 1, 1, 1 here, 2, 2 here, 4, 4, 4 here, and 5 here. So these are the two operations we can do. The operations cannot be performed in an array before if the array becomes empty. After each operation, every element gets unmasked. So the next time you can either double it again. We call an array of integer be reachable if we can obtain from array A by some number of described operations. Your task is to count the number of reachable arrays of length k. So the problem statement is like this. We have an array so on. If I have to go by a literal problem statement, it says mark the first element and every element that is not equal to the previous element. Either delete the marked element so this becomes just 4, 1, 1 or double the marked element. Wait, the array is sorted. I okay, I didn't even notice this and ended up solving for a generic version. Ah, it was a quite important constraint. One more thing I would state is that even if this is not given to us, then also we can sort it. Then also we can solve it. And in fact, the solution I wrote in the contest was without the sorted array. So let's discuss both of these versions. If we double the element, our elements become 2, 2, 1 is also doubled. Only this 4 is double, this 4 is not doubled. Then only this one is doubled. So we have, and then this 5 is also doubled. So actually, initially, if I don't have my Simlink handy, like earlier I was coding something, I realized it's wrong. If I knew like just the doubling work, we would have done it. And this is where we are. Like any questions, anyone on the problem statement? Then the problem statement asks us to find of length n. That length k we can form. Any questions, anyone on the problem statement first? If there are no questions, then I think my generic algorithm would be as follows. First, I will delete some elements. some elements, and then I will double it. Start doubling. Because like if I have to write the operations like this, delete, let's say if we mark delete as crossed, we double using this arrow. If we have operations like this, means double, this means delete. Then you can notice that whatever we double here will essentially get deleted here. So this is as good as not doing anything over here. Same goes here as well. Whatever we double here will get deleted over here. And if I try to simplify it a lot, this my whole operations remains like this. First some delete, then we keep doubling it, and so on. So like overall, this is where we would be deleting sometime, and then we would be doubling sometime. And like why does deleting and then doubling are not same? And then doubling is not same. One thing we said, like when you double it and when you delete it, then it's as good as not doing anything. But why is that not the case for first deleting and then doubling? Like we have seen this here as well. When you deleted some elements, you were left with just 411. And now when you double it, you will end up with only this one doubling, this one doubling. This 2, 5, and 1 is always gone. Yeah, like because some segments will completely vanish when we delete it. Delete them. So this is the idea we have. And like idea I am not yet sure. So what I am saying is, instead of looking this array like this, can I look at this array which says 2 appears 2 times, 2 appears 1 time, 1 appear, like let's first solve for the sorted array. Like let's take one sorted array. we, we say 1 appear 2 times, 2 appears 3 times, 3 appears 1 time, 4 appears 2 times, 5 appears 3 times. Then we double, essentially means do a +1 here. And we can keep doing a +1. And when we are deleting is, this is as good as saying doing a -1 here. So what we really care about is like how many times each element appears. We don't really care about the exact elements themselves because none of the elements will repeat. So because the array is sorted, all the ones would be together, all the threes would be together, all the fives would be together. This is not a valid example because this is not sorted. If it's sorted, then all the ones would be in starting. So we only care about each element appears. And based on that, we are done. And how will our delete operations look like? So, like once we know that one, two, one, three, frequency, if this is the frequency, and so on, then what we can do is like we can figure out if we do based on this frequency, if we do 5 delete operations, we know the elements that will still survive. That will still survive. Is that okay? Like only if we do 5 delete operation, only those element that appears more than 6 times will survive for us. And this is the whole part over here. So we will try to figure out whenever some element vanishes, we will try to figure out how many elements would be there. Or I would put it this before vanishing the element is going to vanish. Count if we can start doubling. That's where we are. Like essentially, like if I know 1 appears 2 times, 2 appears 4 times, 3 appears 2 times, 5 appears 10 times, 6 appears 12 times, then first I will keep deleting it. This 2 becomes 1, this 4 becomes 3, this 2 becomes 1, this 10 becomes 9, this 12 becomes 11. Now, since in the next delete operation, this 1 and 3 are going to get deleted, now start doubling here. Total, we have 5 elements here. So, like the current length would be 1 plus 3 plus 1, 5. 1 plus 3 is 4, 5, 14, 11 is 23. And we have 5 elements so far. So on every double, you will add 5 over here. And you can just check if by adding 5 you can reach k or not. That's the first time when you will check. Then you delete the elements from here once more. This is gone. This becomes 1. This is gone. This becomes 8. This becomes 10. Now do operation one more time. This 2 becomes 1. This 8 becomes 7. This 10 becomes 9. Now if we delete something, this 2 will also be gone. So we check current length. This would be 1 plus 7 plus 9, which is 17. And we have 3 elements still remaining. So now if we start doubling, every time we would add 3 elements over here. So on. So we need to check like if we can get the required k or not by just adding 3 here. Then after doubling, this 1 will also be gone. This 7 will become 6. This will become 8. You will keep doing it. At last, this 6 will become 1. This 8 will become 3. Your length would be 4. and then you have two elements, so you can do +2 +2 and still check it. Yeah, like anytime a number's frequency is 1, we start doubling to check if we can get k or not. And then we delete it again and we keep doing it. So, sir, we are doubling when we have at least one character at frequency 0. Yes, that's correct. So, there are two things over here. Yes, subtracting one from all the elements will be expensive. Or actually, it won't be. If we just keep the track of non-zero frequency, then this is not at all expensive. Because how many times you can delete 111? You won't be able to delete more than n times. In each number, you will remove some of the x frequencies by 1, but still, like the sum of all the frequencies is n. So after you subtract n times, you will end up with a 0. So if we keep a track of all the non-zero frequencies, then we are good. Like that would still be an order run. Like because we are not explicitly doubling, we are only subtracting. For double, we are just checking if doing ++3 always will give us the required result or not. So if we only keep the count of non-zero elements, then we are done. We can remove the one subtract min -1 as well. That's also fine, but I just realized we don't really need it. So this is actually the idea for this one. We first keep a track of all the frequencies. Output was count the number of different arrays we can get. So my idea is like the count of array is strictly dependent on how many different elements you have. First, we keep a count of frequency of all the elements. Right, check that one. While B is not empty, we have a C. If X is greater than equal to 2, then do a pushback X -1, which is like decreasing the frequency. First, we check if we have 1 or not. If we have 1 in the array, count the number of still remaining elements. Count the number of and if count is less than equal to k, and then k minus count is a multiple of length, then we increment answer plus plus. And then we take all the elements, subtract 1 from them, and we replace this with the current element, and we are done. Like the idea is like this for loop will run only n times. Wait, 1 second, where am I missing something? Okay, we don't have to push only. So this was problem C for the sorted array. Any idea how do we solve for this problem if the array was not sorted? In the question, in the contest, I solved for a non-sorted array. The idea, like because the array was sorted, we knew that all the ones are together. No, we cannot pretend it's sorted. If we have an array like this, yeah, like if yeah, essentially you are right. No, like that's not true as well, right? For example, if you have this array, then you cannot pretend that these two blocks will always be same, because the first time when you delete, these ones will be gone. You would be left with one and one from here, three here, three here. So effectively, these two blocks have now merged. Next time, only this three and this one will double or get deleted. Actually, looking back at it, I realize the solution I have will still work, right? Or I'm still doubting the solution I coded. Like, will it work for the non-sorted array? Yeah, it should. No, it won't, right? Yeah, actually, I'm now thinking back whether the solution I coded works for non-sorted or not. Like, my idea was ki, like we still keep the track of the segment. Along with that, we also keep which element is involved there, so that we can merge whenever we want. One appear one time, one appear one time. Now we can merge them into one appear two times. No, I think we can still do that as well. So that was the primary difference you need if the array was not sorted. Like in this case, it's sorted, but how do we solve for the version when it's not sorted? The idea is same. We find all the segments, just that this time we also keep the track of the element that is in that segment. So after this, we have this segment. Like the remaining part still remains the same. First, we check do we have a one or not. Like this time, we are keeping the pair here. If we have a one, the solution is still the same. And we cannot just subtract one this time. Now we iterate on all the elements. If the frequency of the element is 1, then this is 1. Value is this. Frequencies. This is your frequency, right? If the remaining frequency is 0, you skip it. Then you check if we can merge this with the previous element or not. If yes, then just increment the value of the previous element by required count. Otherwise, put this element with this frequency. We swap it and we keep going. And that is how we can solve it even for the case when the array is not sorted. Mhm. Okay. Why is it not? Right now we are solving for the problem C. Okay, we need to move on from this subtraction. Yeah. So this a minor change, like not just frequency, we need to also keep the track of the element that's repeating. And merge two consecutive segment whenever the values there become same. And that is how you would sort for the non-sorted part as well. The time complexity is still order n. And this is where we are with problem C. Any questions, anyone on problem C? If not, we will move on to problem D. If you want to check the rating of a problem, you can use clist.by. If we are decreasing frequency one by one for all in the sorted area, shouldn't it be TLE? No, actually no, right? If you look at the sum of all the frequencies, that's n. Total number of elements were n, right? So sum of all frequency is n, right? Then it doesn't really matter in which order we subtract elements. Like you cannot subtract more than n times. The order we subtract after n subtractions, everyone will be 0. Everyone is 0. Also, the crux of the problem is once the value becomes 0, you should throw that out so that you don't try to subtract that 1 to minus 0 to minus 1. So the crux is this part, like you keep the value only if the count is still 2. If count is 1, just ignore it. And this is usually like amortized time complexity is how we say. So this is where we are. Any questions, anyone on the problem C? If not, then we will move on to problem D. Yeah, it says problem B is 800 or something like that. I will at least rate it 1000 or something. Yeah, like at least I don't see it to be very simple enough solution that it would be 800. It should be 1000 or 1100, something like that. So, like, I believe this was the brute force solution people were saying about B. It does works. We can try to prove why this n square works, but yeah, we will move further. Any questions, anyone on problem C? Or at least do react something so that I know that we can move further. And most of the folks, I believe, were stuck on problem C3 or problem 4, right? So that's where I should be focusing more on. Okay, let's move on to problem D. You are given two strings A and B, consist only of digits. In one operation, you can choose two adjacent characters in either of the two strings and replace them with their sum mod 10. For example, from the string 57246, you can obtain the following strings in one operation. If we combine 5 and 4, their sum is 12. We take mode, so we keep 2 here. And 246 remains the same. 57246, then we take sum of 7 and 2, which is 9. The string becomes 5946. If we take 5724, then these two gets combined into their sum, and this is the array. Or if we take the last two elements, their sum becomes 10, it becomes 0, and we are done. So the problem says, like, at every point in time, we can take two adjacent elements. And if their sum is more than 10, we take it modular time. And it asks us to find, can we make string A and B equal? After every time the length of string decreases by 1, we can do operations any number of times. Can we make string A and B equal? And if yes, then what is the maximum length that can be made equal? So like our operation is like this, and so on. We take these two elements, we replace it with their sum mod 10. A2. Then we can take these two elements and replace it with their sum. And so on. Question is equal. Basically, can we make these two strings exactly same? We are given two strings actually, not one. If yes, what is the maximum length? of equal strings. This is where we are. Any questions, anyone on the problem statement? Yeah, we can modify both the strings. We can do this operation on both of the strings. And actually, that's how we would have to do. Otherwise, if we cannot change B, then we know what final string we want. So first question is, rather than finding the maximum length, can you find whether can we make these strings equal or not? Forget about the maximum length. Is the answer yes or no? Because in case of no, we have to print -1. Yes, this is going to be DP. Not sure why someone has added a greedy tag here. I can't think of a greedy solution. Agreed, like the sum mod 10 should be same for both of the strings. How do we realize this? Let's first forget about mod 10 altogether. How does adding two character becomes a plus b is either a plus b or a plus b would either be a plus b minus some multiples of 10, right? So if I look at the overall sum, we would just be subtracting 10 whenever we overflow. So at last, if we have a just one number remaining, then that number would be equal to overall sum mod 10. Like if I look at a, sum of a is let's say 55 and sum of b let's say is 70. Then doesn't really matter what operations we do. Doing a mod 10, at last we would receive overall sum would be 0 or 10 or 20 or up to 70. And overall sum in this case would be 5, 15, so on up to 55. But if these two strings were supposed to be equal, then their sum should also be equal, right? So if the total sum mod 10 for both of the strings are not equal, then we cannot make these strings equal. Is anyone clear why that should be the case? Because whenever you are taking something mod 10, you are just deleting, subtracting it by 10, 20, 30, 40, something like that. So if you had 55, you may reach 45 once, you reach 35, 25, 5, so on. If you have 70, you can go to some 60, 50, 20, so on up to 0. But these 60, 20 up to 0 and this 55 up to 5 can never be equal. So we have the condition that sum mod 10 of both the numbers should be equal if the answer is yes. This is a necessary condition. Now, can you think of one way to make elements equal? Forget about the length. Can you make one way to make elements equal? Both the strings equal? First, we have proved that if sum is not equal, then these strings can never be equal. Now, we want to also prove that if sum mod 10 is equal, then there is at least one way to make strings equal. That's how you would decide answer is impossible or not, right? So my idea is like change, yes, reduce everything to 1. Change A to 1 digit. This digit would be equal to sum mod 10. Change B to 1 digit, like do operation in any way you want. If you make it a digit 1, then the final digit would be sum mod 10 only. And there is no way about it. So this way you can get at least one digit equal. Now this is where we are. Any questions, anyone so far? So like now the idea is like let's try to see what exactly is happening in this operation. Let's start with this array 5. Like we realize that sum must be equal, right? Let's try to write a prefix sum here. We have 5 here, we have 12 here, we have 14 here, we have 18 here, we have 24 here. Prefix sum is also the way, like if we combine all of these into one, our value would be 14. That's one more reason why we want to look at the numbers. Or if we combine these two elements, then the value here you would get would be 18 minus 12 mod 10, because that would be the difference of the numbers, right? Why prefix sum idea comes in? Because if L to R is combined into one, the digit will be prefix sum of first R elements minus sum of first L minus 1 elements. This will give you the sum of elements between L to R and take in mod 10. This is one reason why you should be looking at the prefix sum. Any questions, anyone? Like why looking at prefix sum should be the natural idea over here first thing? Because whenever you see something where you need range sum or something and the value is the array is static, you should always at least look at the prefix sum. Now what I am saying is, if you combine these two elements, your new array becomes like this: 5, 7, 6, 6. And if I look at the prefix sum again here, prefix sum would be 5, 12, 18, 24. If I combine these two, this would be my new array. Like let's forget about first doing mod 10 or something like that. And one thing that you can sneakily notice over here is this is as good as saying taking this prefix sum array and deleting 14 from here. These two are same array. So essentially saying that if we combine two elements is as good as just deleting one element from the prefix sum array. Is anyone still with me? You can notice here, like when we deleted 2, the resulting array had same prefix sum only. Any questions, anyone so far? Before we jump on to the next part here. Yes. And next, then my next bold claim is, if I have the final array, it would be first few segments combined, next few segments combined, next few segments combined, next few segments. Let's say this is how A looks like, and B looks like this. Let's say this is how we obtain B, and these two are same somehow. Let's say after combination, this is how the array became. Then you have a condition that sum of these two elements part mod 10 is equal, right? That's the only would, because in fact that would be the digit that will get formed when we combine all of these elements into one and all of these elements into one. So for the first part, taking value mod 10 will be same. If I look at the original B, so whatever we get from sum of B here, sum of the A here, their mod 10 should be same because that would be the digit you will get when you combine these two parts. Is anyone still with me? So I'm saying if this index is L1, this index is J1, then prefix sum of A up to I1 mod 10 is equal to prefix sum of mod J1 up to P. Now what would be the digit that will form here? Let's say this is index I2, this is index J2. Then in the first part, this would be from index I plus 1. So on the first side, you will get I2 prefix sum I1 of A for I1 mod 10. This would be the digit you would get on the left side, right? Sum of the elements in that range mod 10. On right side, you will get this. J2 prefix B J1 mod 10. This should also be equal, right? Because the second digit in both the strings is equal. Any questions here so far? Based on the first two characters, this is what we can say, right? Now the bold claim is, if we know that this mod 10 and this mod 10 is equal, then I am saying we can remove this from both the sides. then prefix mod I with mod 10 should be equal to prefix B J2 mod 10. Now, can we say this like this would be character C1, this is character C2. So based on C1, C2, I say these two. Or another way to put at it is like if the strings are equal, then sum of first two strings would also sum of first two characters if we have two equal strings. Sum of first two characters will also be equal to character mod 10 because everything is in mod 10 will also be equal. Even from this, we can reach at this equation that prefix sum of elements up to I2 and prefix sum of elements in B up to J2 mod 10 should be equal. That's how you can get the second character equal. One way to look at it is like if we have two equal strings, then sum of first two characters will also be equal. And you can directly get prefix sum I2 would be like the sum of characters up to first two characters, and prefix B would be sum of characters up to two characters. Or one way to look at is you found I1 like this, you found second character like this because the first character was equal. So these two parts will have the same remainder mod 10. You can remove it. That will also give you this equation. So what I can say, like everyone is here with me so far, right? So one way to look at this problem is create prefix sum arrays. Take everything mod 10 and try to pick some characters in increasing order such that the arrays are equal. Like for example, if prefix sum of A is like this 2, 4, 1, 9, 0, 5. After taking mod 10 and prefix sum of B is like this 1, 0, 3, and let's say 5. Then we have to pick some characters from these two arrays and we have to pick the same character every time. So for example, we can pick this 1, 1 from here. We can pick this 0, 0 from here. We can pick this 5, 5 from here to get 1, 0, 5. Essentially, like now you have two arrays. You have to pick same substring from both of the arrays. And that same, whatever same substring you can get, you can always get that string by doing operations in some way. So problem reduces to checking some string can be formed is like checking if that substring exists in the array. And that's all we need. So like if we have to see if we can get 5 length substring here or not, then we have to see can we pick 5 characters from both the arrays such that the order of the elements is same. Final string of length 5 is equal to checking if one substring of length 5 exists as subsequence. And like also important concern is we will have to always take the last character. We cannot avoid that because some of the all the elements would still be same. So we have to always take the last character and we have a freedom to choose between the remaining parts. And if you want to find the longest, then the problem becomes find the longest common subsequence from prefix sum. And this is actually quite common. Like, how do we find the longest common subsequence from the two strings? If you Google it, you will find many solutions as well. Like, I just type longest common and like there is a problem on lead code. There is a Wikipedia page. There is gigs for gigs. A lot of algorithms here. Even we have one video from Striver 4 years ago on how do we find the longest common subsequence. Lead code problem a lot ago. Wikipedia as well. So like now this problem reduces to something that we already know how to solve for. How do we count the longest common subsequence in the array? And that's where we are. Any questions, anyone so far? Are you still with me? Like this problem is reduced to one of the problem that many of people you would now be aware of how to solve for. Like initially when A, B, mod, sum, 10, things like that were given, that was a bit difficult. Now we have reduced it to something that you already know. And for the folks who don't know how to find longest common substring, we define dpij as longest common substring, longest common subsequence, not among first I characters from A and j characters from B. If this is how we define our DP states, then if AI is equal to Bj, then dpij we can say is equal to max of, like you will have many ways to put it. One possible transition is take this character and solve for dpi minus 1 j minus 1. And you can always drop the last character and check what is the best thing you can get from dp I minus 1 up to j. This is when you are trying to find the best subsequence when you simply don't match AI character with something. Or if you don't want to match anything with j, then it becomes checking with dpi j minus 1. And this actually solves the problem for us. And this is overall solution for problem D. You can refer to many of the other videos as well. First, we take S and T as input and we try to find the prefix sum from it. We take all the, we keep taking the prefix sum mod 10, we put it into the array, we get the required sum. Yeah, this is n square. But the constraints are just n is up to 5 into 10 to the power 3, b is up to 5 into 10 to the power 3. Total sum of length of a and b is up to 10 to the power 4 only. So overall, it would be n square, but would be within time limit only. Like if you just look at this t up to 2 into 10 to the power 3, a up to 5 into 10 to the power 3, b into 5 into 10 to the power 3, then that will be TLE. But this is the important constraint actually, that even the sum of length of a and b does not exist 10 to the power 4. That's why like this n square will get an AC. This ensures that we cannot have a test case where length of a is up to 5 into 10 to the power 3. Total number of test cases 2 into 10 to the power 3. Total number of length, because we cannot have a test case where we have t as total 2000 test cases, but length of a and b up to 5000, 5000. Because in that case this will get TLE. Yeah, like I also coded o n cube in the 10 into n square in the solutions, but I realized we don't need it. Initialize everything with -1. We start with it. I would start with n-1, j-1. If I is less than 0 or j is less than 0, we have reached the bound. We cannot get the required answer. If we have seen this state before, then we return the required value. Otherwise, we say current value. We ignore the ith character. We simply ignore the jth character. And if AI is equal to bj, then now we can take these together and we ignore both of them. And this is actually your problem D. Any questions, anyone on problem D? If not, then we can move further. What is Y combinator? You can look at my blog. Like, what is Y combinator? Like, this Y combinator is not the Y combinator that funds you. This is not this one. So you can check this blog. It says precisely the detail why I use Y combinator, why it's helpful. So this is problem D for us. Like you can in practice kick out one of the dimensions from here as well. For the sake of simplicity, I won't jump into that, but you can do it in this time space, time complexity as well. Okay, I will skip the explanation part, but if we don't do anything over here. Comma dpj minus 1. This will also work. Like here I am abusing the fact that the last characters are same. If they are not same, then you have to take maximum of dp or things like that. But this is one way you can decrease the time complexity. I won't go into the details, but essentially the idea is, okay, you can iterate elements in such a way that you can remove one of the dimension, and that's usually useful when you have to optimize for number. So this is where we are. Any questions, anyone? If not, then we will move on to problem E. Just react something. Any questions, anyone? Just let me know if we can move further. We are at problem D right now. Then we also have problem E with us. Okay, this got hacked somehow. Okay, we need to. Wait, why? This should work in my opinion, right? Does this also fails? Interesting. Like, can anyone see a mistake over here? This is like skipping the ith dimension. Mhm. Does this helps? Yeah, that's fine. So yeah, this works. This is problem D. Any questions, anyone so far? Because I am closing the poll based on my poll. Only 5% of the people were able to solve fifth or sixth problem. So I am assuming most of the folks would like to know problem E. At least the ones who were able to solve 3 or 4 problems. Like I have done LCS in lead code, but can't able to find how to use such logic in Codeforces. How can I improve? Like the only solution I have is practice, practice, practice. And you can actually refer my advices on this channel. Like you should start doing ABC because ABC actually is an ideal contest for these problems. Like such educational problems appear a lot of time in AdCoder beginner contest. And that's one way you can improve yourself. Another way is like the upsolving one. I have an advice on upsolve as well. Yeah, like this one. Like you should know the standard techniques where you are already have an edge, like you know LCS and all. Then the next technique is just upsolve, upsolve, upsolve. I'm not sure if I explained upsolve, upsolve, upsolve or not. But yeah, this essentially means ki if you are able to solve 3 problems in the contest, after contest you should try to solve 2 more problems. And if you keep repeating it over time, then there would be a time when you would be able to solve the fourth problem, and then you would be trying to solve fifth and sixth problem, and so on. So this is where we are. Any questions, anyone so far? If not, we are moving to the next problem. Okay, let's move further. It says product of the closures. Let the closure of positive integer x be formed by the following binary string x. Write x in the binary form without leading zeros. Concatenate the obtained string with itself infinite times and call that result cx. For example, the binary of 1 is just 1. And then you keep repeating the same string, you will get an infinite string. Or if you have to look at the 4, you first write 4 in the binary and then you keep repeating 4. What a string. Or if you are in 9, then you first write 9 in binary and then you keep repeating it. That way, you would get a long string of the infinite number of binary characters. Each character is 0 or 1. Then it says we define the product of closures C of x and C of y be the binary string that is obtained by taking bitwise AND of the strings. For example, for 4 and 9, this was the infinite string, this was the infinite string. Now we take bitwise AND for all the string. This 1 1 becomes 1 0 0 0 1 everything. This would be the string you get. Any questions, anyone so far or everyone with me, like what the problem is asking us? Then it says we are given three integers L, R, and N. Among all the numbers in the segment from L to R, find two numbers X and Y, like two numbers X and Y, which is between L and R, such that the closer, like the bitwise and we obtain, is the lexicographically smallest possible. Essentially, it says lexicographically smallest is the smallest defined as the smallest string and so on. And we have to print first n strings of this product. Or I will revert this problem into this way. We need to find all the products of length n and then take the smallest product we can get. That is also fine. Because if the two strings are equal up to nth character, what doesn't really matter what's after them. Whatever is the smallest will have the same characters we have right now. So this is where we are. And n is up to 1000, LR is up to 2 into 10 to the power 13. So any questions, anyone on the problem statement? I am trying to skip the visualizations rather directly jumping into the solution. So if anyone has any questions on the problem statement itself, let me know. If not, then we will jump further. Okay, then how do we get started with this problem? We obviously cannot brute force or L and R and take the length of n digits and then compare among them. So what do we do about this? Any ideas, anyone? So like I think I can one option is I can directly give you the final solution I have. It's way too much optimized. But I think let's go into small pieces. Actually, the way I arrived at the solution and the way I wrote the solution. Like each of these submission has one optimization more than the next one. And at last we optimize it to the point it cannot be had. So how do we go about this? Any ideas, anyone? Or like what is the brute force solution that you can think of right now before I start my optimizations? Let's do it this way first. Let's write numbers from 1 to 10 in binary. Let's just do it. Two in binary, four in binary, five in binary, six in binary, seven in binary, eight in binary, 9 in binary, 10 as well in binary. Like I deliberately use different colors here. These are the numbers you have, right? First thing is we can try to group these segments into some way. We can say that we have 1 0 0 0 1 here for this string. For this string, I would say we have 0 0 1 and a wildcard. For these four strings, I would say I have 0 1 and two wildcards. You can notice that whatever we put into this 0 and 1, it will land up with some of the numbers here. Then we look at these numbers, and then I say like I have 1 0 0 as well and some wildcard. That wildcard would map to one of these numbers. And then this string would be 1 0 1 0. So essentially grouped numbers in such a way that they have same starting prefix and then you have some wildcards. And like I am not going to probably I will skip how we go into these wildcards here. But can you see if we can somehow figure out such wildcards which have same prefixes and then some bits that are wildcard? Then your life becomes a bit easier, right? Because you know that the infinite string here would be like this. 1, whatever was replaced in that wildcard. 1, whatever was replaced in that wildcard. 1, whatever was replaced in, like let's say this wildcard is C. 1 and X. Then this becomes 1X, 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 and so on. And here, if let's say if we replace this wildcard with 1, Y, and Z, then your infinite string becomes like this: 1, Y, Z, 1, Y, Z, 1, Y, and so on. This would still be 1, X. This is 1, so on. Like you got some wildcards, right? Now, based on these wildcards, you can figure out what elements, the elements that are fixed, for example, here would always be 1. This wildcard would be XOR AND of X and Y. The next one would be wildcard of 1 and Z. Next one would be wildcard of 1 and X and so on. Like once you have these wildcards with you, based on this, you can figure out like which bit maps to which element and how you make elements equal. Like you are still with me, right? This is one brute force you can try to do. One more claim I forgot to make. Like the number of such wildcard groups you can get is 2 log AI only. This is a fact. And the way you can see is you can visualize it based on a try. I won't be proving this part because that like that is an homework exercise. If you can somehow figure out these wildcards, then the number of such groups would be log to an AI only. With such log to AI groups, you can find all the wildcards you have. The idea would be like, think of it like as an infinite try. You go left side, you get 0. You go right side, you get 1, 0, 1, 0, 1, something like that. And each subtree in a try, if you fix the number of bits as 30, each subtree in a try corresponds to some element based on what path you traced. And if you are looking at some wildcard, then you will have those elements there. Or if I have to really prove it, then I would say like this. Let's say this is a try, and so on. Let's say this is an infinite try here. Then you trace 0, 0, 0 here, you will reach an element which is 0, 0, 0. You trace path here, you will get 0, 0, 1. When you trace this path, you will get 0, 1, 0. When you trace this path, you will get 0, 1, 1, and so on. So the numbers that are appearing here is the binary representation of all the numbers. And if you stop yourself as this node, then the number you can get in the bottom of this strip would be 0, 1 and the wildcard. And these corresponds between 2 and 3 only. So you can think of it like an infinite segment tree from between 0 into 2 to the power 30 minus 1. If you go on the left side, you add 0 at the end. If you go on the right side, you add 1 on the end, and you can keep dividing the range. This range would be from 0 up to 2 to the power 29 minus 1. This range would be from 2 into 2 to the power 29, comma 2 into 30 minus 1. Then you further divide and you can keep doing it this way. So we were here where we said that if we know what are the wildcards, then we know which bits will match with each other and we know what to fill for the wildcard. Right? Now my next claim is, let's always fill wildcard with a 0. Why put a 1? Because you want to minimize the AND, right? If you put 0, then that bit definitely becomes a 0. If you put 1, then if the other bit is 0 or 1, based on that, you decide what the final value is. Why put 1 in the wildcard? Just put 0 always. Then your life is simple. This you can't do anything here. This 1 will definitely be 1. You put 0 here, it became 0. Here, if you put Z1, the number would have become 1. But if you put 0, the number became 0. Here, if you would have made x1, this would have been 1. But if you put 0 here, like your string is decreasing, right? This is becoming 0. This is becoming 0. Becomes 1. Why do we even put 1 in the wildcard to begin with? Let's just put 0 there, man. Because we are making our life only miserable by adding some wildcards and 1 and forming those strings. So this is the next optimization. The only case when you may want to put wildcard is, like, let's say you use the same group. This was one element from this group and one element again from this group. Then it makes sense to choose one element as 0, 0, one element as 0, 1, whatever element you choose. Essentially, like, you can choose one element as 0, 0, and another element doesn't really matter. You can choose any set of 0, 1, 1, 0, 1, 1, doesn't really matter. Whenever you take AND, you will again get 0 only. Only if we choose one set for both x and y. Same wildcard group for x and y. Choose x as all zeros and y as any number. Because wherever you have a wildcard, one side, one bit is always zero. So another bit, whether you have zero, one, whatever, the end will be zero only. That's the only case when we would be choosing elements where our wildcard will not be one. But what I'm saying is this is as good as assuming that you made both those things as zero only, because the result you are getting is always same. Is everyone still with me so far? Any questions, anyone so far? What I have done so far is I looked at the range, tried to form it in a group that has same prefix, some wildcard bits. That was the first thing I did. Then I made a claim that number of such groups you can get will not be more than 2 log AI. So in this case, it's practically 62 times 30. And then no, like by group, I mean numbers like this. Like we are choosing X and Y, right? This was the binary string I said I initially created. I said saying one is a group like a 001 and no wildcards. I'm combining 2 and 3 into the same group where I say that they start with 001 and a wildcard. Then I am saying 4, 5, 6, 7 is same as choosing a number which as 0, 1 and then few wildcard. Like actually, like we cannot have initial zeros in the binary representation. So like the actual numbers would be like this. So now how you match different groups, your story changes. Like for example, if you just match 1 and x always, 1 on one side, 1 and x other side, one string will always be 1, 1, 1, 1, 1. Another string is 1x, 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 and so on. So we don't have leading zeros here. So like the numbers don't have same length actually. Different groups can have different lengths based on how many starting zeros are same and how many remaining numbers are same. So like this was the first submission I actually made that has been hacked by the way for TL. Like initially the very first submission directly blunt on this was actually a TLE on test case file. This is like a binary loop to figure out all the wildcard bits. Any element we put between would have same set of prefixes and some bits as wildcard. Now I have all the groups with me. I take the first group, I brute force on all the possible set of groups. If I choose the same group, then I was choosing one bit as a one, but I realized I don't really need this for loop again. So this was me trying to set one of the bits as one, but in retrospect, all of this will give me the same results to begin with. So this is the first solution. Like all the next furthers are one observation on this brute force idea and optimizing it. Like here, I was trying to set one of the bits, but I realized it doesn't really matter. I can just leave it as it. I have I am deciding the prefix, and then I am running by choosing some x and some y. The idea would be first get x and y of length and whatever we want. We shouldn't really be bothered about runtime altogether. We can form the string, and like we can start result with everything as one. This is the first brute force solution that gets a TLE, but we have now we will progress more on this idea. Any questions, anyone so far? This should get a TLE. That's right. Now notice what I did really in each group. I took one number that has all zeros, and if there was a need for it, I took all the numbers but the last character as one. So for every group, I really care about the smallest two numbers only. And even going a bit further, what I'm saying is like if we have this group 110 and a wildcard, then we shouldn't even be bothered about this group at all. Because whatever we can get 100 and 1001, that would be the best result we can get. So my next idea was to even combine these two parts into one. And saying that there is really no need to check for 10010 if you have 100 and some wildcard. Like for example, if you have a group wildcard and 1100 wild, then I'm like, just forget about this one at all. This will always give us the better result. Because from this group, we will take the actual numbers we would take would be 100 and only if I am taking numbers from both the group, then I would take 1000001. This would be taken only once. And taking this number and something from here, if I have to choose one of these, then it's really better to take this number, right? Rather than taking 11001010. The length is same. So like in this case, you are getting one, but it's better to put 0 there. Even for this number, although we don't have a wildcard, but we have other number that has a 0 here, and everything is 0 here. So there is simply no reason to take a group like this. Are you still with me? Like, see, I am trying to, like earlier we had 2 log AI groups. Now I would try to make them only log AI by saying that if I have found a wildcard group 100 and some binary string, then choosing a group like this 1100 and 3 wildcards will never give me a better result. So I can simply ignore it. Like now, like implementation will become a bit of heavy, but essentially this is where we are. Like for example, if my L is like this, and if my R is like this, let's say we have few more ones here. Then I'm saying like let's start looking at from the bits. As long as you have equal bits, you don't really have a choice. Every group will have same one. Now you found a 0, you found a 1. Then I am saying solve for taking this is 1 actually. Now solve for one group like this. This is the first time then bits mismatch, right? So keep this 1 here and 0, 0, 0, 0, 0. This number would be between L to R. And if you really have an option available with us, you can also go for these two numbers. That's all. You shouldn't look at the numbers which are more than these two, whatever the R is. So you just keep this group with you, and then you start solving for L, which is 1, 1, 0, 1, 1, 0, 0, 1, and R, which is 1 less than this one, which would be 1, 1, 0, 1, 1, 1, 1, things like that. Now you move a bit more further. Like essentially, I'm saying choose this R as X, this as Y, solve for 1, or just and then just keep this number with us. Just keep this number with us, and then change our R boundary to this number -1 in order to probe for more groups. Now we again have same bits. Again, you got the first time a 0 and 1. Then you keep 1, 1, 0, 1, 1. You keep 1 here, 0, 0 here. That's the only number you care about, and you keep going it a bit further. And then now you take this number and solve for this number -1 and L to R. This way, every time you found a mismatch, you kept 1 from there and made all the other bits 0, and you kept moving further. That way, for every mismatch, you found some bit or the other and things like that. So like this also handles for the cases when you don't have same length. Let's say if this is your 1, this is your R. You found a first mismatch. You keep R equal to, you take one number for your possible candidate to probe for. as 1 and then all of these as 0. And if you have flexibility, just check your answer with 10000 and 1000001. If you have flexibility, do make a check for it. And then update your R, like update your R to this. Your new R is keep this 01, these numbers. This would be the number less than the number you have found here. Now you found again a mismatch. That way you would find some log n candidates, some log AI candidates. And some answers if you choose the same group. Now you have log AI candidates with you, where every number is like this, some number, and then few zeros on it. And the next number would be like this. These numbers are actually same. Like this is one iteration you can do, right? The moment you found a mismatch between these two numbers, you said just take 1 year, everything 0. And I would try to probe, like I still have that log square solution with me. Just that I'm saying, like, we don't really need to take a lot from here. We can keep this number on table with us and we can try to solve for a subsequent smaller sequence as well. So that way we have right now log AI candidates with us and some answers based on choosing the numbers from the same group. Like this is one more optimization we can do, right? Do you have any questions with me? Like notice how we went from 2 into log AI groups to just log AI groups by saying that the numbers on right are actually redundant for us. This was my submission over here. Instead of doing via segment tree flow kind of stuff. If bits are equal, we keep them fine. Otherwise, we keep the number by removing all the bits from there. That is your left to our endpoint, and you decrease your R by 1. So, like nowhere, I am assuming that you have the same length of X and Y. What I am probing for is what are the candidates that I should be looking for. Although my range is from L to R, where L is can be from 1 and R can be 2 into 2 to the power 30. But I am saying I don't have to look at 2 to the power 30 number. I am decreasing that the optimal answer I can get would be some odd 30 candidates, only one of them X, one of them Y. So this was actually the submission where I have reduced my probe to just log AI numbers only. I still keep the group same. This is something that I got hacked for. Looks like it's not still not optimal, but yeah. Or another way to look at it is like the way I am finding these numbers is as follows. Earlier I was using segmentary kind of stuff for logging. I start with these numbers. If the bits are equal for left and right, we skip it. Otherwise, New R is L taking a OR with last all the bits set. You take the number which is new R plus 1 up to R. That's the range you are taking. And you update your R to new R. And if you ended up with same numbers as well, you keep both the numbers as well. My remaining algorithm is still same. Like I believe I can keep the original. I can keep the same numbers for X and Y. It's still log square number of candidates to check for. Now we initially have log AI candidates with us, and we are checking every pair of candidates. So log AI. The length is up to 1000, so time complexity is log AI into n for each test case, and we have t test cases. And notice there is no constraint on sum of length of n, and this still gets a TLE. 1000 here, 1000 here. 30 into 30 is 900, so 9 into 9 into 98 or something like that. In contrast, this submission got an AC, but it's still a TLE. That's fine. Hmm. So the next optimization we had was something that I did not actually prove. Like what I am saying now is the very first time we took a number out, right? Whenever things mismatched, this number should always be one of the two numbers. Like if your L and R were like this, then when you found this mismatch, the number you took out was this 110000. So I'm making a bold claim that this should always be one of the two numbers, either X or Y. For the Y, the other test case would be 1 1 0 0 0 1. That's the only test case when you to take numbers from the same group. Otherwise, you take this as y and just look at the other number from x. Like we shouldn't be checking the numbers later on as well. And the reason here is like you have this 1 1 0 0 0 0. Next, you would try to make replace this r would like this. And then you keep going further. This would be one case over here. Or if this r turns out to be power of 2, then your number would be like 1 0 0 0. Like either L and R has the same bits. L and R is same. In that case, your number would be like this. 1 1 0 1 0 1. L is like this. R is like, let's say we have a mismatch here. Then it's optimal to choose number like this. X has 1 1 0 and everything. The place where you found a mismatch, take everything as 1. And Y as the place where you found these two numbers would definitely be between these two numbers. And when you take AND of these numbers, these 4 will give you 0. And these values will always be same for both of the numbers. So the answer is actually very deterministic. If the length or number of bits in X and Y is always same, you can look at the common bits, make them same, and otherwise you are done. So if bits of X and Y are not same, then the numbers would be like this: 0 1 0 0 1 0. Let's say L is like this, R is like this: 1 1 0 1 1 0 1. Then you just take the greatest power of 2 you have. Like the first time you found a mismatch, the digit you are forming is this 1 0 0 0 0. This is the greatest power of 2. Take this and try to get something from the L. And you will notice that if you also have 2 into 10 to the power minus 1, then choosing is the most optimal one. Or like otherwise you can go over the same set of candidates you already have. Like you will have same set of bits from here. And the first candidate you find, you take it on, or you can brute force the log AI candidates you have. Again, that's fine. Choose this as the one candidate because like this is the best number you can have, right? You got one, then some number of zeros, then just one, some number of zeros, and the gap between the zeros is the longest possible. I did not strictly prove this lemma ki like this is always the best one, but you can try to visualize it why this would be the best one. And I simply assumed it and submitted it, and that was the end of the story. That was the last optimization. Like the groups I was forming, I just sorted them in the decreasing order. This is the best. This would be the number that would be formed by you have 1 at the first mismatch place between L and R, and everything behind them is 0. So this is either 2 to the power k, the largest 2 to the power k you can get between L and R, or if the bit length is same, then some prefix and 2 to the power k is 0. So in both of these cases, this is always one of the numbers, and you can just take the other number from the same group, same log AI iterations, and you call it a day. Like, because now overall solution, because one number is fixed, you have log AI candidates for the other number. Time complexity becomes log AI into n, and with t test cases it becomes t. So 1,000 into log AI 30, which is 3 into 10 to the power 1, is this is well within the time limit. So we don't really need to optimize a bit further. So essentially the TLDR is, if the length of L and R number of bits between them is same, then you don't really have much choices. There would be some set of numbers that will always remain. And look at the common prefix for L and R, keep them and make all the other bits 0. Otherwise, find a 2 to the power k which is between L and R. Take one number as 2 to the power k and another number as whatever the segments you can get, and solve for it. So this is where we are. And this wraps up my problem. Any questions, anyone? Any questions, anyone? I I thought I have a brief idea for F, but then I realized I possibly does not have it. So I will try to jam 15 minutes on F. If I find something that I believe will work, then we are done. If not, then we will wrap it up. Like in contest, actually, I did not read F because one or the other thing kept coming up. And yeah. Any questions, anyone on problem A to E? Or any other question in general? Yeah, actually, I don't watch football. Mostly cricket is the only sport that I follow, and sometimes chess. Like I don't understand chess, like all the openings and all, but I like people winning. Indian players winning. So, any questions, anyone? Thanks a lot, all the people who are here so far. Like usually, I used to prefer previous contest problems rather than some rating wise problems. To be honest, that was my preference because and but different people may have different ideas. Let's just see for F. I briefly have a spoiler with me, like while reading at the announcement blog, that we need a trip or something like that here. Let's see if we can get something working. I will probably skip coding and all. But yeah, it says Monocap is a student at Provincial University in Berlin. The summer holidays have just begun and they will last for next Sundays. Monocap has long trip of going to capital city of Berlin. So he will choose one day I among these days, arrive in the capital on that day and spend the rest of the holidays there. The capital of the Berlin is not very cheap city and the Monocap has zero Berlin dollars with him. Naturally, this is not enough to visit interesting places and buy souvenir. Therefore, on some day in the capital city, Monocap will long run short. We are given an array A. If the value of array A is like now you iterate on the numbers. You if you the next number you have is x, and if your current value is less than x, then you add plus x to it. Otherwise, you subtract x from it and you keep going. If it was for just one array, we were good. But the problem asks us to solve for all the suffixes. Like let's just reset the whiteboard. Long run sort is if we have some elements with us, we start with count, some count equal to 0. And then we go for x in A. If count is greater than equal to x, then we do count minus equal to x. Else we do count plus equal to x. And then we have to report count at last. This was still busy, good, but we have to solve for all the suffixes. For all suffixes. Like if it was all prefixes, it was the same, like you just iterate it and you are done with it. So my idea is as follows. Let's say we have solved for A up to AN. And we know that if we start from J, we will reach Bj at last. If we start from J and then start doing operation, we know that final value would be some Bj. Then how will we solve for this overall problem? And then if we have to append X in the starting, then I would say like, now if I have to find the new, like so far these were the answers for I plus 1 up to this. Or let me put it this way, like we have this array B where we have destination value if we start from B0, B1, B2 up to Bn. Now if we have to append X in the starting, then how will the number change? For the numbers from 0 to x minus 1, you would actually be adding x to it. So for here, you should fill from the next one is bx up to b 2x minus 1. Like this is for I plus 1. I, if you know the results from I plus 1 to the end, like what if you start with 0 and do operations from I plus 1, what number you reach? If you start from 10, you do operations from I plus 1, what number you receive? Then I am saying if our initial number is between 0 to x minus 1, this number changes to x up to 2x minus 1 when we go for I plus 1. If we have numbers up to x to n, then we go to I plus 1, our numbers become 0 up to n minus x. So now we have some form of iteration. If we have an array A, array B, we should look at number from x to 2x minus 1. put these numbers in starting and then take numbers from 0 up to n minus x and put these numbers here. Like x up to 2x minus 1 came here and 0 up to n minus x came here. Like here it sounds a bit fascinating. Like someone said they need a persistent tree or something. Like essentially what we have is like we have an array and we are moving jumbling numbers around. Like moving this sum sub array to starting is still the idea from the trip. Like trip would actually be an homework exercise, like quite advanced. Like that was the hardest problem in the first online contest, ICPC online contest I did, and just 2 or 3 people solved it back then. But like essentially you can assume trip to be something like that. You have an array and you can move some segments up and down. So cutting out this segment, moving it further is easy. But how do we retain the same segment here as well? Someone said persistent trip. That can actually work. You keep these half numbers with you. That gets added here and you add more numbers here. Persistent trip will definitely work here. Like now I'm going like this is a problem that only 20 people solved. So it's natural unless I'm going quite detailed on every single piece, you will hear ideas that you may not have heard before, but that's fine. Like I'm just trying to jam around. So persistent trip definitely works. And let's see what folks at the top did. Looks like a trip. You split it, you merge it, you move elements around. Like I saw someone stating that even trip works. That's something I could not figure out how that was working. Can F be solved into persistent trip? Definitely yes. Just normal trip is enough. I cannot switch pieces yet. Let's see what this guy is doing. We take all the values of A as input. Okay, honestly, I don't understand this solution and I will most likely wait for an editorial only. Like, I can see how to solve it using persistent trip. Whether that will get a TLE or not, I cannot comment on. There is actually one USACO problem as well. So yeah, I think I am skipping F here. Persistent trip, I know, but I will just wait for an editorial. So this is okay. So yeah, I think this is all mostly problem A to E, and that's where we are. Thanks everyone. So I initially thought I will discuss A to F, but I don't know.